Okay, welcome back to the Cocoa Academy. Today's lesson, this is day 4 of our index unit. And today we will continue working with exponent laws to simplify powers. For this lesson, you will need the handout, the packet with this title. Chapter 2, Indices, Day 4. And it is a single page with the front and the back handout. We're going to be learning 2 more exponent laws today, and then we're going to be applying all the laws we know. You do have an assignment here, pages 59 to 61, numbers 8 through 10 in your textbook. Every other problem. So let's start with a warm-up. So far we have learned 5 index problems, and I want you to think how many of them you can recall. And let's try to express them in terms of variables. X to the A and X to the B. And I'll give you an example. If I am multiplying 2 powers that have the same base, X to the A times X to the B, I can simplify that by adding their exponents together. So that's X to the A plus B. Pause the video for a moment to answer the rest of these, and when you turn it back on, you can check your work. Okay, I hope you paused it and actually did this work, so you're checking it. If we're dividing numbers with the same base, X to the A by X to the B, it is X to the A minus B. We subtract the exponents. When we raise a power to a power, such as X to the A to the power of B, it's X to the A times B. If I raise a product, in other words, something like xy to the power of a, we distribute that a, so we get x to the a times y to the a. Last one, when I find the power of a quotient, such as x over y to the power of a, we also distribute it, so we'd have x to the a over y to the a. So those are our 5 rules that we have learned so far in this unit. Okay, what we're going to add to this are 2 rules, 0 exponents and negative exponents. And these can be a little bit confusing, so I'm going to explain them both to you in the same way. Let's take a number like, let's say x to the, let's just say 3 to the power of 4. You probably know that that is 81. Hopefully, 3 times 3 times 3 times 3 is 81. Now if I were to divide this by 3, in other words, divide it by 3 to the first, I would subtract my exponents right here to get 3 to the third. And that's going to equal 27. Notice we've gone from the 3 to the fourth to 3 to the third. If I divide again by 3 to the first, I'm going to get 3 to the second equals 9. If I divide again by 3 to the first, remember, we subtract our exponents. 2 minus 1 gives us 3 to the first. Oops, I wanted to write that in blue. And that equals 3. Starting to run out of some space. So I'm going to recopy this up here as 3 to the first equals 3. Again, if I divide this one by 3 to the first, and this is where we get our 0 exponent, okay? So we know that 3 divided by 3 is 1. And if I just look at my exponent rules and I subtract my exponents 1 and 1, I have 3 to the power of 0. So that's this first rule right here. Our 0 exponents is right here. that any number to the power of 0 is equal to 1. Now with negative exponents, the way I like to show that is just to continue with this pattern. Notice that we started with 3 to the power of 4. I divided by a 3 to the first. I subtracted my exponents to get 3 to the third. When I divided again by 3 to the first, 3 minus 1, subtracting the indices, I get 3 to the second. When I divide again by 3 to the first, 2 minus 1 is 3 to the first. This up here was just recopying. And then 1 minus 1 gave us 3 to the 0. So if I continue that pattern, and I divide by 3 to the first here, and by 3 to the first here, I'm going to get, let's see, 3 to the negative 1, that's 0 minus 1, equals 1/3. And look, suddenly we are dividing. We're coming up with a fraction right here. If I do this again, and I divide by 3 to the first, and divide by 3, I'm now going to get 3 to the negative second, because negative 1 minus 1 is negative 2, and over here I'm going to get 1/9. And another way to write that would be 1 divided by 3 squared. So negative exponents refer to not repeated multiplication, but this time repeated division. So that 3 to the negative second equals 1 divided by 3 squared. And 5 to the negative third equals 1 divided by 5 cubed. It's a little bit counterintuitive. I know that you want to probably make this one be negative 9, but instead it's 1/9. And this was 1 divided by 125. So I have a place to put in some rules down here. And on your handout, you can just copy these two right here. Any number raised to the power of 0 is going to be 1. And a negative exponent is the inverse of that number with a positive exponent. I know that's a little bit confusing, but inverse is going to mean the reciprocal. Or, said it a little bit easier, flip it over and change the exponent. So 3 to the negative second is the same as 1 divided by 3 squared, and x to the negative third is 1 divided by x cubed. So how do we use these? Let's do some example problems. If you'll flip your page over to the back side. 3 to the 0, well, we just apply our 0 exponent rule that any number raised to the power of 0 is 1. So that's that answer. For B, 2 to the negative second, we have a negative exponent, and we want to think of that as its reciprocal, so 1 divided by 2, and with a positive exponent. So that's 1 divided by 4. You can always check that with your calculator if you'd like. I'm pretty sure it will agree with me. This one, 5 to the 0 minus 5 to the negative 1. Any number to the power of 0 is 1. And 5 to the negative first is 1 divided by 5. So 1 minus 1/5 is 4/5. And this one is one of my favorite uses of a negative exponent. Remember that we're going to distribute that to both here and to here. So I get 2 to the negative second over 5 to the negative second. And we said what this means is we're going to flip these over. So this one is going to come down here and have a positive. If I flip the top to the bottom, the same is going to refer to happen here with this 5. I'm going to flip it up here and make it positive. So the answer to this one is 25 divided by 4. Now another way to do this problem is to start with this negative and distribute it first. And what that tells you to do is flip that fraction over. So if I use that negative, it's now 5 divided by 2 to the power of 2. Notice that I no longer have a negative exponent. I now have a positive exponent. Now 5 squared is 25, and 2 squared is 4. Either way, we got the same answer. Okay. Some other ones that I can do real quick. These are not on your handout, but I'm going to do them for you real quick. 5 to the negative second is 1 divided by 25. I'm sorry. It's 1 divided by 5 squared, which is 1 over 25. Negative 2 to the fourth. Well, this is the opposite of 2 to the fourth. So remember, we're going to think of that first and make our answer negative. So 2 to the fourth is 16. Get negative 16. This one is a negative exponent, so I'm going to make it 1 divided by 3 to the power of positive 4, which is 1 over 81. Okay. Let's write these problems here without brackets or negative indices. So we have to distribute this negative here and here. And it's a power of negative 1, which means we don't have to multiply by anything. So I have 5 to the negative first over x to the negative first. It's negative first, which makes that 1/5 times 1 over x, and that's 1 over 5x. Another way to think of it is, as I said with the last one, deal with the negative first. That's going to make it 1 over 5x to the power of 1. Distribute your 1, and it stays 1 over 5x. And again, either way, we get the same answer. In B here, only the x is getting the negative. Only the x has that. The 5 is just 5. So it's 5 times 1 over x, which is 5 divided by x. In this problem here, 3b squared times the power of negative 2. We're going to distribute it. I'll have 3 to the negative second times b to the negative fourth. I'm going to put both of those in the denominator with positive exponents. So 1 over 9b to the power of 4. Let's see. Okay, these are not in your packet on your handout, but I'll do these for you real quick. And I've got some rules here on the side that you can refer to. Here I've got a power times a power, which means I add the exponents together. We're doing this rule right here. Difference is I've got a negative, so negative 3 plus 17 is x to the power of 14. In this problem right here, x to the negative 10 divided by x to the negative 10, I'm applying the rules of quotients where we have a power divided by a power with the same bases, and when that happens, we subtract their exponents. So negative 10 minus negative 10, which is the same as negative 10 plus 10, and that's x to the power of 0, which is 1. You could also think of it as a number divided by itself equals 1. This one here, this last one on this slide, is again the same as this rule, but we're working with some negatives. I have to add those numbers together to get x to the negative 20th. And if I was going to write that as without a negative exponent, it would be 1 over x to the 20th. Okay, we have just a handful more. If I want to write these with just powers of 2, 3, or 5, 8 is 2 to the power of 3, so 1 divided by 2 cubed. I can take this out of the denominator and write that as a negative exponent. I'm kind of doing the reverse of what we did before. With this one, 1 divided by 9 to the power of n. 9 is 3 squared to the power of n. Again, if I want to take this out of the denominator, I want to flip it over, I just have to change the sign of the exponents. Okay, so see, 25 is 5 squared divided by 5 to the 4th. Remember, if we're dividing a power by a power and they have the same base, in this case 5 and 5, we can subtract their exponents and get 5 to the power of negative 2. Good. So, just very quickly, this one is only the b to the power of negative 1, so it's a divided by b. In this case, both of these are to the power of negative 1. Oh, and I should mention these 4 are not on your handout. My apologies. Here we get a to the negative 1 times b to the negative 1, which is 1 over a times 1 over b, which is 1 over ab. Another way to do this problem would be, again, like I said before, deal with that negative first. So you have 1 over ab, all to the power of 1, and any number to the power of 1 is itself. We have the same answer. 5 squared over 5 to the 4th, we actually did on the previous page as the 25 over 5 to the 4th, so we don't need to do that one again. And this one, hey, let's do with this one the way I did it up here in this problem right here. I'm going to distribute that negative first, and what's going to happen is it's going to make these change places. The 2 goes down, the 5 comes up. It's all to the power of 1, and so it is just 5 divided by 2. So that's a lot to take in. We've gone over 7 exponent laws, and they're listed right here. So if you multiply 2 powers together, you add their exponents. If you divide 2 powers, right, as in this one, you subtract their exponents. If you raise a power to a power, you multiply their exponents. If you raise a product to a power, you distribute that exponent to here and here. Same thing with division. A quotient to a power, you distribute it, and then anything to the power of 0 is 1, and a negative exponent actually means division. So x to the negative a flips it down to the denominator. Likewise, 1 over x to the negative a flips it up into the numerator. So those are your rules. And what I'd like you to complete, I'm going to go back to our first slide, which lists your assignment. On pages 59 and 61, 8 through 10, you can just do every other problem, in other words, A, C, E, etc. And that would be some good practice for you. Thank you for listening.